times we get to find a lot of different stuff. Something which I have seen, something which you guys have seen, and something we both have seen. But today's class is about something which many of us missed out. So that is finding last 3 digit, 4 digit, 5, 6, in that way any digit. So let's have a look into this. Finding last digit greater than equal to 3. In this kind of thing, I never found it in a book or study material or in a YouTube video or in any kind of Facebook videos or whatever you say. So I figured it out. Let's do it something on my own. So let's have a look into it. Okay. So for example, if you have a very big expression, okay, and they ask you to find the last digit. So like 17 to the power 256. 17 to the power 256 they ask you, and they ask you that, okay, please find out last 3 digits. For that, I'm going to give you a very structured case. 17 to the power 256. So what is the closest? So first, step 1, relate with 1. So it's a binomial pattern of relating with 1. It's like a plus 1 whole to the power n kind of format. So every time you get a 1 and a power will be expanding. So every time you will have a n, nc1, a n minus 1, 1, nc2, a n minus 2, 1. So you don't need to bother about this 1 even. Okay. So you don't need to write it. So then nc3, a to the power n minus 3, and at the end it is only 1. So this is magical over here. In most of the cases, we'll be needing the very last or the second last term, which is nc n minus 1, a n minus r plus 1, and clear? Seventeen to the power 256 is quite like that. So we will go to 17 square. So that is 289. So 17 square whole to the power 250. Sorry, 128 then. So 289 whole to the power 128 then. And 290 minus 1 is 128. Voila! Now this is our trace. Now we have got that 1. Our job is almost done. That is the only thing you need to do in finding any last digit. So 290, so what is the expansion? So 290 whole to the power 128 minus 290 whole to the C1 127 plus 290 C2, and in this way we are proceeding as fast as we can. So where we are ending? We are ending at the very last 2 digits we need, where this 290 will not be that much evident, because we are wanting to find the last 3 digit. So we need to take it a relatively better care of this part. Okay, so the last ones will be pretty interesting over here. So 128 is the power. Okay. Oh, sorry. I made a mistake over here. 128C. Yeah. C2. So here the very last one will be plus minus, in that way we are going in an alternation manner. In an alternation manner we are going. So it is like plus 120. How I got it? It will be plus because here I am using even. Every time even is used, it's a plus. So 290 whole to the power 2 minus 128C, 127, 290, and the last one is plus 1. So we need to worry about anything else here. So this is our sum look like. So everything has a 290. Remember that for last 3 digit you need to write last 3 expansion. Now last 4 digit you need to write last 4. Last 5 digit you need to write last 5. But don't worry, these are very small expansions. Okay, for like 128C, 126 is nothing but 128, 126 factorial and 2 factorial, so 128, 127 by 2. So as you can see, it will be coming to a relatively lesser value. So that is our benefit. So first of all, in the first 128 to 128 to 2, so in this all 126 terms, you can take this 290 here as common. Okay, so this will be your very crucial part. This will be your very crucial part. So because with respect to tens place is coming, okay, so 290 is everywhere. But all the powers are here, this power. So if I just write it here, 128C, 127 and 290 cube here. So 290 cube has to end up with 3 zeros, 3 zeros. So in the last digit, all these values, still these values end up with 3 zeros. So we can write 0, 0, 0 for all these terms. That has to be taken common. So that has to be taken common, like 1000. 1000 is taken common, and some expressions we can just put it as n. Don't need to worry about that. Okay, so the last three terms are the crucial, because this thing end up with 0, 0, 0. So plus, all you have to calculate is this 3. So 128C 126 into 90, 290 square, 128C 227 into 290 square, and plus 1. So as you can see, things become relatively very easy once you do it in this fashion. Okay, so this is a 290 square. All you can do is 128 into, okay, so I'm just writing it here. So 128, 127 by 2, this part, into 290 square. Then 198, 287, this you must be knowing. So this is 138 itself. Still I'm showing you 127 and 1 factorial. So this is 128 itself, and plus 1 and plus 1. So this is 64 into 127 into 290 square. This you need to calculate, and this will be giving you the value which you can just do it over here. Okay, so 64, 127. There's a shortcut for it. I'll be applying it. So 64 into, so let me just do it for 290 and 290, 29, 29. Okay, so there will be 2 extra zeros over there. Okay, 2 extra zeros, only 2 extra zeros. So you need to find the third last digit. So 290 is at the last third digit. Okay, so it will be 0, 0, 0 and itself. So remember this. Okay, so let's do it. So this is 3000. This has to end up with 2 zeros, and 4 sevens are 28, 9 nines are 81. So have a look. 4 7 4 7 9 9. So 4 sevens are 28, 9 nines are 81. So it has to be a 8. So without doing a single big calculation, I am just doing it. So 128 into 290, that we have to do. 128 into 290 will give you 37,120. So I'm just doing it 120 plus 1. Rest of the thing is very easy. So it is like 801 minus 120. 801 minus 120 if you do. So you will get your answer directly as to be, this is, so if we just do it, 681. That's it. So this is the last 3 digits of any expansion. So let me give you a roundup on this. All you have to do, take the expansion, do it like this, take it to the square, make it a 90s expansion, expand it fully, and if it is last 3 digit, keep the last 3 terms, last 2 digit, keep the last 2 terms, last 1 digit, keep the very last term. Okay, so, and all you have to do, this we took some time to do the calculation, but I figured out the shortcut over here, so which I've told you. So this is about the magical last 3 digits.